Hello class, and welcome to Math 112, Pre-Calculus Algebra. Today we are doing a Chapter 1 review. On your online written notes, you do have lots of examples, audio, different illustrations on how to better understand Chapter 1. I'm just going over a few key problems in Chapter 1 so you have a better understanding of what I put on the written notes. If I see parentheses, open circle, a broken line, or if I see the less than greater than sign, that means that I do not include that given number because it is not a part of the solution. When I see brackets, a closed circle, a solid line, less than or equal to, greater than or equal to, that means that I do include that given number because it is a part of the solution. Whenever I'm dealing with the infinities or I see a infinity symbol, I want to remember to surround them with parentheses every time. Do not include brackets. Always parentheses on those. I'm on section 1.1 real numbers on page 11 of your textbook. So I'm just going to do an example of each little part so you can understand. And then also I want you to remember what we talked about right here on this first page. Now, let's look at the next page. I'm on page 11. It says, express the interval in terms of inequalities and then graph the interval. So I want to look at number 50. 50, I have a bracket, -6, comma, -1/2. Right here, I want to first graph it and then write the inequality. So what I'm looking at now is written in interval notation. I want to now graph it. So when I graph it, I want to see that -6, and I know that's going to be to the left of 0. And then I want to see that -1/2, which is also to the left of 0. So if I need to distinguish that, I can go ahead and put just a little 0 right here to know that these two numbers are to the left of 0. Now, thinking back to our previous note, if I see brackets, I'm going to have a closed circle. So I'm going to have a closed circle on 6, -6, and also a closed circle on -1/2. This is a compound or double inequality, so I'm going to shade in between. Now, when you write your inequality, read what you wrote. I started with -6, and I ended with -1/2. And I do have things in between shaded. So we're going to let that be represented by X. So anything that's in between -6 and -1/2, we're going to represent X. If I look at -1/2, I notice that shaded to the left. So if I'm going to the left of -1/2, that means it is less than or equal to -1/2. If I look at the -6 and I look to the right, it is now greater than or equal to -6. But I want you to notice how I read it. I read X and then I read to the right. Then I went back to X and I read to the left. So I said X is less than or equal to -1/2. Then I went back to X and it says X is greater than or equal to -6. So start in the middle where X is and read to the right, then read to the left. And that helps you to understand how to also read the information and how to graph it. But I want to stress that you can read it any way you like. I can read the entire inequality from left to right, or the entire inequality from right to left, or I can start with X and read outward. I do prefer reading outward, especially if I am graphing that inequality. Let's look at number 51. So 51, I have bracket 2, comma, infinity. Let's graph it first. I'm going to start with 2. I see my 0. I'm going to move over and I see 2. So 2 is in brackets, so it will be a closed circle again. And it says it's going to infinity. So if it's going to infinity, I'm going to shade everything to the right of 2. And I also want to include that arrowhead to let me know I'm going on to infinity. Now to write my interval notation, to write my inequality, I'm going to start off with x, and x is any number that is greater than or equal to 2. Notice I didn't write it as a compound or double inequality because I didn't have a start and a stopping point. I started at 2, but it went on to infinity. So only one number should be shown on my inequality. X is greater than or equal to 2. So if you look at the graph and look at the inequality, it makes sense. The first part, which is brackets 2 comma infinity, is my interval notation. The second part is my graph. And the third part is my inequality. Now, also on your notes, we talked about Desmos. So I have asked you to create an account for Desmos and practice plugging everything into Desmos. This is very, very important. So if you notice, I created folders, and you can also go on YouTube and look at how to create these folders. They're very easy. They have lots of videos on YouTube on how to use Desmos. So please take advantage of those resources. But I create a folder for the problems, and we looked at just a few. So we didn't look at 55. Let's look at 55. So on 55, notice I can't see the graph. I need to turn the graph on. So where it says number 55 on the open circle, tap on that open circle, and now I can see number 55. At the top right, you have a wrench. Click on that wrench and click on projector mode. That's going to help thicken up that graph some. And then you just take your finger and you can expand or condense the graph as much as you need to. And then you can also move it as well. So just take your fingers and you can move the graph. Okay? Very easy. Notice that on number 55, it is an open circle at -2 and a closed circle at 1. If you look at some online information on how to do how to graph the inequalities on a number line, and they may give you some different notes on your YouTube video, but this is an easy way that I like to do it so I can see what's what. I actually plotted the point -2, and plot the point 10. But be careful that you write your answers the way that you see it in your notes, not write it as ordered pairs. So very careful with that part. I don't want to confuse you on that. Very, very important. All right, let's go on. So now, we know a union is a U symbol, and an intersection is an upside down U symbol. When you see union is an and statement. That means that all the numbers that I'm looking at, I'm including in my statement. And on an intersection is different. It's an or statement. Intersection is, I need to put both parts. I need to find out what do both sets have in common, and that goes in the intersection. So whatever both sets have in common goes on the graph. So that being said, I want to look at number 66. So union, I'm including everybody. So all the different numbers I see goes on that number line. But for an intersection, I'm only including the parts that both sets have in common. So we're going to look at 66. 66 says, graph the set. I have -infinity, 6, intersect 2, and 10. Okay, I do want to see my 0. I'm going to write down all the numbers I see on my sets. I see 2. Go down, I see 6. Go down a little more, and I see 10. And I do see -infinity, but we can't do -infinity. That's everything to the left. So we're just going to do 0 to indicate we're going on to the left, and those arrowheads indicate we're going on to -infinity. Okay, so if I look at this intersection, I want to get everything that's in both sets. So if I look at both sets, I am noticing that in both sets, I see 2, I see 3, I see 4, I see 5, I see 6, and I see everything in between 2 through 6. Any decimals, square roots, whatever, fractions, all that's in between 2 and 6 also. Okay, not just those whole numbers, those integers. But I do see a problem. On the second set, 2 is in parentheses. 2 is included in the first set because it's in between negative infinity and 6, but it's not. It is not in the second set. So where 2 is, I have to start at 2 because that's the lowest number that both parts have in common is 2. But 2 is not included in the second set, so I have to do an open parentheses there. Now, what is the largest numbers that both sets have in common? And that number is 6. If you notice, 6 is closed on the first set and 6 is in between 2 and 10. So it is part of the solution. So I'm going to have a closed circle on 6. And then we shade everything in between. And that is how you do a intersection. Okay, so that is it for section 1.1. Let's go on to section 1.6, which talks about complex numbers. Now, some things you need to remember about the complex number. I do want it in the form of A plus BI. Also, I equals the square root of -1 and I squared equal -1. When you talk about complex number involves a real part, which is your A, and your imaginary part, which is your B. And when you think about complex numbers, you usually see the variable I. So in math, when you see I, you are going into those complex numbers where you have a real and imaginary part to that expression. Let's just do a few examples of these to make sure you understand the concept. I want to start with number 9 on page 64. Number 9 on page 64 says, find the real and imaginary part of the complex number. I have -2 minus 5i over 3. I'm going to rewrite this and say -2 over 3 minus 5 over 3i. So my real part is your A, which is -2 over 3. And your imaginary part is your B, which is just the number. Do not include that I. And also include the sign in front of 5 over 3. So it'll be -5 over 3. And that will be my imaginary part. And that is it. Let's go on. I want to talk about number 33. Number 33. The direction says evaluate the product and write the result in the form of A plus BI. Also, numbers 17 through 26, as I'm working out 33, numbers 17 to 26, those are very simple. You're just combining like terms. So you need to recall your Math 100 notes on how to combine like and unlike numbers. Very easy. Multiplying can be a little different. So let's talk about the multiplication part though. Now, these are called conjugates. They are conjugates because everything in the binomials are the same except the signs in the middle. Everything is the same except the signs in the middle. That's why they are called conjugates. With conjugates are great because if you think about the forward method, if I identify these as conjugates, the outside and inside is going to give me 0 every single time. So I only need to multiply the first and the last, and that's it. If I identify these are conjugates, I only multiply the first and the last in the forward method. So let's do that. 2 times 2 is 4. 5i times -5i is -25i squared. You do need to review your properties of exponent rules. When you multiply, you add the exponents. When you divide, you subtract the exponents. When a power is raised to a power, you multiply the powers. When the base is raised to the zero power, it equals 1. And when the exponent is negative, you move it on the opposite side of that fraction bar to make it positive. That is something that was one of the first things you learn in Math 100, properties of exponents. So make sure you study those rules again. But let's continue on 33. I remember that if I see I squared, it equals negative 1. So I have 4 minus 25 times negative 1. And then I have 4. Two negatives make a positive, 25. So my final answer is 29. Number 39 says evaluate the quotient and write the result in the form A plus BI. So I have 2 minus 3i over 1 minus 2i. I'm going to multiply by the conjugates of the denominator only because I want to see the form of A plus BI. I see 2. I see 1 in my numerator, 1 in my denominator. I only want to see 1A plus BI. So I need to get rid of that denominator. So to do that, I multiply by the conjugate. The conjugate is 1 plus 2i. Now I have to remember in math, what I do on one side, I must do to the other side. Now, I have multiple binomials here, so I'm going to use the for method. In my numerator, so if you don't like the way this looks, you can just put them in parentheses so you can see that 4. But we know parentheses mean multiply, or it groups things together. But we're going to multiply. Apply the for method, or you can apply the box method, which I did an example of the box method in your written notes. Now, in my numerator, I notice that these are not conjugates, so I must do the entire for method. 2 times 1 is 2. Outside, 2 times 2i is positive 4i. Inside, negative 3i times 1 is negative 3i. And then my last, negative 3i times a positive 2i is negative 6i. I got to add that exponent squared. In my denominator, these are conjugates. So I'm good if I only did first and last. 1 times 1 is 1. Negative 2i times positive 2i is negative 4i squared. Very good. Now, I also know, and I do have it more detailed in your written notes, so refer back to those for more detailed notes. But I do know that when I see I squared, that equals negative 1. So on my next step, I have 2 plus 4i minus 3i. 2 negatives make a positive 6. Then I have 1. Negative 4 times negative 1 is a positive 4. Now, so make sure you understand how I set that up. Also, it's a little more detailed in your written notes. So look at that if you need better direction on that. We're going to combine like terms. I know 4 minus 3i is just I. And I also know 2 plus 6 gives me 8. So in my numerator, I have 8 plus I. In my denominator, 1 plus 4 is 5. So right here, I do want it in the form of A plus BI. So I'm going to separate each part and say 8 over 5 plus 1 over 5i. And that is my answer. One thing I do want to stress, let's look at 55. 55, it says evaluate the radical expression and express the result in the form of A plus BI. So I have the square root of negative 3 times the square root of negative 12. So going back to that beginning of my notes, I know that if I see the square root of negative 1, it equals I don't see the square root of negative 1, but I can write it out and see it. I'm going to rewrite the square root of negative 3 as the square root of negative 1 times 3, because negative 1 times 3 is still negative 3. I'm going to rewrite the second part and say negative 1 times 12, because that still equals negative 12. Right here, you have to be extremely careful, because you may want to say, okay, from what I learned in Math 100, I can say negative 3 times negative 12, and that'll give me a positive. But we're dealing with complex numbers, so you do not want to work it out like that. That would be incorrect. You do want to break up that negative 3 and that negative 12 to pull that negative 1 out. Because I see the square root of negative 1. That is where I will write a I. So I will write I, the square root of 3 is still left under that radical, times, bring down the second I, and keep that square root of 12 under the radical as well. Now, 3 and 12 are my positive numbers. I can multiply those together. And I know I times I. Remember that when you multiply, you add the exponents. So I see I squared times the square root of 36. We know from our previous note that I squared equals negative 1. So I have negative 1. We know from previous math classes that the square root of 36 is positive 6. So negative 1 times 6 is negative 6. And that is my answer. So look at that example to help you understand number 57. On your written notes for 57, notice that I rewrote the two binomials in the form of a plus bi, and then I completed the for method. On that final answer, if you notice on 57 that none of these terms were like terms. So we have 4 terms. But in the book, they wrote the real part, which was the 3 plus square root of 5. And then they wrote the imaginary part last. So they still wrote the answer in the form of a plus bi. But instead of seeing a binomial, I see 4 terms. Let's go on to section 1.8. So on 1.8, it is imperative that you read it, because this is really going to help you get the concept of everything else we're going to talk about throughout this class. You really need to be very comfortable with those very first rules that we talked about in this class on the open closed circle, the true false, less than equal to, broken line, solid line. You really need to understand that, because we are going to touch on that all throughout this class. On section 1.8, it talks about inequalities. And the main thing you need to remember about solving inequalities is that when you multiply or divide by a negative number, you have to reverse the sign. That is your note number 5 that's on page 82. You have to remember that rule. That is one of the main things that kind of sets solving inequalities different from solving equations. So page 82, rules of inequalities, make sure you read that. On page 83, read the sign of a product or quotient and the guidelines for solving nonlinear inequalities. And nonlinear inequalities are the graphs that are not straight. They're not horizontal, vertical. They don't have those positive, negative slope graphs. The other types of graphs are your nonlinear graphs. And we will study parent functions later, and you will see those nonlinear graphs as we talk about parent functions. Now turn to page 89. And I want to stress on 89, number 33, because we are looking at a compound or a double inequality. And we're also going to talk about when we multiply or divide by a negative number, we reverse that sign. So the direction says, solve the linear inequality, express the solution using interval notation, and graph the solution set. So we are doing 3 things. We solving, we graphing, we writing it as an interval notation. And we want to make sure that we're doing all 3. If you notice, I have a front, a middle, and a back. Notice that X is in the middle. My goal is to get X by itself, as I would any type of problem. To get X by itself, I want to start off by subtracting A. So I'm doing my additive inverse. The 8's equal 0. They're opposites. Opposites equal 0. Then we're gonna combine our like terms. So I have negative 10 less than, and notice I'm reading from left to right. Negative 2x less than equal to negative 9. Again, notice I'm reading from left to right. I didn't start from the middle and read outward. So again, like I told you on our previous note, you can read these different ways. But the key point is that you got to know what you're reading and know how to graph what you're reading. That's what's important. When you're graphing, try to read in the middle and work your way out. And it makes it so easy on how to graph these. Now, next step, I need to get rid of that negative 2. So think about that rule number 5. Rule number 5 is read a little different, but all rule number 5 is saying that when I multiply and divide by a negative number, I have to flip those signs, reverse those signs. The negative 2's cancel to 1. So I'm left with x. Because I divided by a negative number, I have to reverse that sign. So instead of me writing less than, I'm going to say greater than equal to 9 over 2. Go ahead and clean those signs up. Instead of writing x greater than, I'm going to say x less than positive 5. One thing I want to stress, when you're doing compound double inequalities, those signs are going to be turned the same way. So you're not going to see a case where you have a greater than, less than. You have the signs turned a different way. You're not going to see x greater than equal to then x greater than turned that way. You're not going to see them turned that way. You're going to see them turn in the same direction. And that's another way to kind of tell if I'm doing what I need to do correctly. Now right here, I want you to notice that the larger number is to the left, 5, and the smaller number, 9 over 2, is 4.5 is to the right. I do not want my final answer to look like that. I do want my smaller value to be to the left and my large value to be to the right. Now I want you to go back and keep reading. This says x is greater than or equal to. So when I do my rewrite, I'm going to still say x is greater than equal to 9 over 2. Okay, so again, I say x is greater than or equal to, and then when I wrote it, it still says x is greater than or equal to. Now, on this side, it says x is less than 5. So when I write it here, I'm going to say x is less than 5. Now, I do have it the way I want it to look. I want the smaller value to the left, the large value to the right, and the signs are still reading the same way. I only flip my signs one time only. Okay, so I want you to make sure you understand that you only reverse the signs one time, not 2, 3 times, just one time. So make sure you know that. Okay, now let's graph this. So to graph it, I'm going to put my 0 here just as a place. I know 9 over 2 is 4.5. 5, just scoot it over enough to where you can see it. So don't be so concerned about the spacing. You want to be able to see your answer. So space it out just a little bit so you can see your word. Okay, so at 9 over 2, the circle is closed. And at 5, the circle is open. And I'm going to shade in between. So X represents everything in between. So if I want to test 4.75 and I want to test it, it's going to be all true. Now right here, this is when you do a compound inequality, it's an all or nothing. 4.75, it has to be less than 5, and it also has to be greater than or equal to 9 over 2. So 4.75 is less than 5. That's a true statement. And 4.5, it doesn't equal 5.4, but it is greater than 5.4. So that statement is true. So when I do my true-false statements, wherever I did not shade, that is a false statement. So if I tested 0 is less than 5, but it's not greater than or equal to 4.5. Okay, so 9 over 2, this is a true statement. In between is a true statement. 5 is a false statement because 5 is not less than 5. That's why it's false. It's a all or nothing. All the parts have to be true or it is false. And then everything to the right of 5, that's a false statement. Because if I test 6, 6 is not bigger than 5. 6 is bigger than 4.5, but it's not bigger than 5. That's why it is false. So everywhere I shade is true, and everywhere I do not shade is false. Now, let's go on to our next directions, 37 through 58. And these are a little tricky, so it is so important that you read those 3 notes that I took pictures of and put on your Evernote. Please read that in very great detail so you can understand how to do it. But I just want to focus on one of these examples, and let's talk about it. 45. 45 says solve the nonlinear inequality. Express the solution using interval notation and graph the solution. If you go on Desmos and you only type in the left side, once I get it to 0, then that can give you an illustration of what the graph looks like. And then you can click on the points wherever it equals 0. So let's practice that real quick so you can see what I'm talking about. So I'm going to open up me a new graph. And I want to make sure my graph is nice and thick. Now, I haven't did the math yet, but you do see it on your online notes, so you can look at that. I have x. I'm going to hit that a squared button, so I see it's a parabola. Then I'm going to say minus 3, hit the x, and then I'm going to say minus 4. Okay, so that's my graph. If you notice, on your written notes, your first step says find the zeros. So my zeros, if I click on the x-axis, I see my zeros are at -1 and 4. Those are where my zeros are. I also can see where my true and false statements are going to fall too. But let's do the math and look at it in more detail. So going back to my note, on 45, I have 3x squared minus 3x less than 2x squared plus 4. Okay, so my goal is to get everything on one side and make it less than 0. So I'm going to write 3x squared, combine some terms as I'm doing this, minus 2x. So I move that to the left, bring down the minus 3x, move that 4 over and make it minus 4, and it's still less than 0. So I have moved everything to the left of my inequality sign, and it's 0 now. Now, combine like terms. So 3 minus 2 is just x squared minus 3x minus 4 less than 0. I want to factor. You have to remember how to factor. So definitely review that. You will be reviewing that on your homework. And also, if you have some good Math 100 notes, review factoring from your Math 100 notes. I have x times x, which is x squared. I need to figure out what will multiply to give me 4 and subtract to give me 3. If I do 4 and 1 and then -4 plus 1, that's going to give me -4 and that -3 I need. After that, this is in factored form. Very important term. The left-hand side of my inequality is in factored form. That is a great thing in math. Put it in factored form. Something times something times something. That's factored form. So I'm going to say x minus 4 equals 0. And then x plus 1 equals 0. Solve for x. So x equals 4 and x equal -1. If you go back and look on Desmos, that's what I did by just clicking on the graph. So what I did was I typed in my left side of my inequality only on Desmos, and I was able to find my zeros here. So whenever y equals 0, that's you finding your 0. Whenever y is equal to 0, that's finding the zeros. Okay, so my next step, I want to draw a table of my values. And then once I draw my table, I can graph it. So I want to go ahead and set my graph first, and then I'm going to do my table second. I have my zeros, which are -1 and 4. I already know that they're going to be open circles because it's less than. But if I'm not sure, include that in your table. I want to find some test points to the right, left of my zeros and in between my zeros. So I'm going to use -2. I'm going to use 0. I'm going to use 5. Any number you want, but keep the numbers simple. Keep them as simple as possible. Any numbers you want. Definitely do integers. Don't start doing decimals and fractions and square roots. Deal with integers only to do as your test points. So -2, 0, and 5 are my test points. Now let's create this table. And you do have detailed written notes, so I'm just going to talk about it here, but you are to look at those notes to make sure you understand how I got these answers. Also, if you have a graphing calculator, you can also look on the graphing calculator to see things too. Also on Desmos, and you're going to see me do a lot on Desmos. I can go to Desmos very quickly while I'm doing my online notes, and I'm going to show you some things on there as well. So if you notice, I wrote down my factored form of this problem into my table, and then I'm going to say true, false. True, false. If it's true, I shade. If it's false, I don't shade. That's all it's telling me. So as I'm doing my notes, look at your written notes as well. All I'm going to do is everywhere I see X, I'm going to plug in -2 on the left side. When I finish working it out, I should get 6. Now, is 6 less than 0? True or false? It is. 6 is not less than 0. Just use what you know. You know 6 is not smaller than 0. You know that's a false statement. Okay, so do -1. I'm going to plug -1 in everywhere I see a X. So when I plug in -1, I'm going to get 0. So is 0 less than 0? That's a false statement. 0 is not smaller than 0. They're equal. Now plug in 0 everywhere you see X. And again, you have written notes on your Evernote to see how I'm plugging everything in. So refer to that. So when you plug in 0, you're going to get -4 less than 0. And that is a true statement. -4 is smaller than 0. Now plug in 4. When I plug in 4 for X, I get 0 less than 0. That is also a false statement. And then when I plug in 5, I get 6 less than 0. And that's also a false statement. So the only statement that was true is wherever X equals 0. So if you go back to your table, your number line, where 0 is, the statement is true. And that's where I shade. So my answer, I want to write it in as an interval notation. I'm going to start at -1 and end at 4. You start and end wherever your circles are located, okay? And that is how you do those problems. You have 2 more examples in this section to look at, and then I also want you to read through the section to get a better understanding. Okay, so let's go to number 89. Absolute value inequalities. And you do have rules for these also, so make sure you please read those rules that are on page 86 of your textbook. Read those rules. 89. It says solve the absolute value inequality, express the answer using interval notation, and graph the solution set. So again, we're doing 3 things. We're solving, we're graphing, we're writing it as an interval notation. But when I'm doing absolute value, one thing I need you to remember every time is that you must isolate that absolute value as much as possible before you start applying the rule. If you notice, the left side, the absolute value is not isolated. I see an 8 and a minus sign. I got to get rid of that 8 and that minus sign. So to do that, I have to subtract 8 on both sides. So I have the opposite of the absolute value of 2x minus 1 is greater than or equal to 6. I'm subtracting that 8. So right here, we know that 6 minus 8 will give me -2. So the next step is I have to get rid of this negative sign here. So to get rid of that negative sign, I have to divide both sides by negative, understood -1. But I got to remember back to my previous rule, number 5 rule, that when I multiply or divide by a negative number, I have to reverse those inequality signs. So I still have to also apply that rule as well as I do this. So I have the absolute value of 2x minus 1. I have to reverse that sign, and then a negative times another negative makes a positive 2. So now I have everything I need. And I have isolated my absolute value as much as possible. And that you must get it like this before you start applying your rule. I'm looking at that less than equal to sign. So when I see less than equal to, I'm going to apply the -c less than equal to x less than equal to C rule. And that's again on page 86. So make sure you read that. You are paying attention to what the sign is showing you to know how to figure out which rule to apply. And the sign tells me which rule to apply. So we know C is 2. C is 2. And my x is 2x minus 1. So we have negative C. So for negative C, I'm going to write negative 2 less than equal to, my x is the 2x minus 1 part, less than equal to C, which is 2. And then it's a double inequality, so just solve for x. Add 1 on all three sides. So I'm left with negative 1 less than equal to 2x less than equal to 3. Divide 2. I'm dividing by positive, so do not touch that inequality signs. So I have negative 1/2 less than equal to x less than equal to 3 over 2. Again, you only reverse the signs when it is the multiplied or divided by a negative number. Very important to remember that. Now, I have solved for x. The goal is to get x by itself, so I'm done. Let's graph it. On my number line, I want to include my 2 parts, which is negative 1/2. I don't want to see that 0 this time, but you can if you want to. And then 3 over 2. Both of the circles will be closed. And I'm going to shade in between. So again, read that x and read outward. And that is my graph. My interval notation, I'm going to start with negative 1/2. And I'm going to stop at 3 over 2. And I'm including those 2 numbers. So again, this is false. This is true. This is true. This is true. And this here is false. Wherever I shade is true. Wherever I do not shade or open circle, it is false. Okay, so that is it for our overview of chapter 1. Please look at your written notes. Please look at your video so that you will understand how to do chapter 1.